Hello, today is June 8th, the day after the midterm. I think all but one person has taken the midterm due to a scheduling conflict. And I am getting those graded today. And right now, your current grades reflect your actual raw score on the midterm. And then I will be updating those after the last person has taken that with your midterm bump if you turned in the sample midterm. So that will be adjusted. So today I'm going to do some worksheets on chapter 7, although we weren't able to have anybody join me. I am going to work through some worksheets for you to get practice with chapter 7. So chapter 7 takes, and we start looking at quantitative continuous data, because in chapter 6 we looked at quantitative discrete data, right? Data that had to be integers or discrete data like a whole person or a whole car, things like that. So now chapter 7, we're looking at continuous measured data. So let's go ahead and look at 7.1 worksheet number 2. It's on page 559. And I'm going to share my screen here. And this first page lets us look at different curves. And you'll remember, like this curve B, this one in the middle here, kind of looks like a little bit like the curve, the empirical curve that we learned about in chapter 3. This says, consider the following curves A, B, and C. Which graph has the largest mean? Okay, so the mean is measured along this horizontal axis. Okay. And so the one with the largest mean, so wherever the center is, that's the mean. So there's the mean, there's the mean. So this would be the mean of A, this would be the mean of B, and this would be the mean of C. So C would have the largest mean because it is furthest from furthest to the right. So remember, we treat this scale down here like a number line. Which curve has the smallest standard deviation? So smallest standard deviation is the smallest spread. So that would be the tallest, skinniest graph is what we're looking for. And so that would be A. So the mean is what shifts left and right. We talked about this in the course pack. And the spread is what makes it skinny or wide. So B has the biggest spread of these three distributions. So question number 2 has us use the idea of this empirical rule and what we know about the curve. We learned in 7.1 that 100% of our data falls underneath this curve, and those percentages are labeled up on top, and the values of the variable are on the horizontal. Variable values are along here. So 91 is a value for the variable that we're talking about here. Now, we don't know the context of this variable. We just know the mean is at 80. We know that. And then we're going to try to use the idea of the concepts that we know about the curve to find these other probabilities. So if the mean is at 80, we know that B here, the probability that X is less than 80, that would be all of this space here, is going to be 0.5, right? So 0.5 or 50%, because half of the data is always below the mean and half is above when you're using the normal idea that this data is normal. Okay. What else do we know? So the probability that X is greater than 91. Well, right here, we have 91 marked and we have greater than 91 shaded. And it says that that area is 0.06407. So approximately 6.41% fall greater than 91. Then it says, what is the probability that X is less than 91? Well, that would just be the complement of this, right? Because we know what it is to be greater than 91. So what is it less than 91? So probability that X is less than 91 is equal to 1 minus the probability that X is greater than 91. So 1 minus 0.06407, which is 0.93593. 0.9359. D says the probability that X is less than 69. Oh, geez, we don't even see 69 on the graph, do we? Let's let's mark where we think 69 will be located, and that will give us some guidance. So 69 should be over here, and the reason I know it's right about in this spot is because 91 is 11 values bigger than the mean, and 69 is also 11 values, but 11 values smaller than the mean. So we don't know anything about standard deviations to use the empirical rule, but we do know data values. So 11 hops to the right gives me this value, so 11 hops to the left should give me the same. So that means beyond 91 is this 0.06407. That means beyond 69, so really it needs right around in here. So beyond 69 should also be 0.06407. E says the probability that X is between 69 and 91. So symbolically, that looks like this. It's between 69 and 91. So between 69 and 91, I'm going to use my pen in this one. That would be all of this between 69 and 91. So we could subtract 2 of this space right here, right, from 1. So if we cut away this space, that would get us between 69 and 91. So if we said 1 minus 2 times 0.06407. That gives us 0.87186. Okay, F says the probability that X is between 69 and 80. So that looks like just there in between 69 and the mean. So if we know the left-hand side of 80 is all of 50% right here, we could subtract beyond 69 from 0.5 and find out the difference of what's right here. So we're saying, what is the probability that X is between 69 and 80? And so that means 0.5. We're going to subtract 0.06407, which is going to be 0.43593. So we did one of these in the course pack as well. They're trickier. You really got to think about that there's 100% of the data under here, and these are symmetric, and kind of using some concepts like that to make your way. The third big question here in 7.1 is all around the idea of how to describe probability. And in our course pack, there's 2 ways to do that. And let's just turn in our course back and find that, what I'm referring to. is on page 177 in your course pack. So on page 177, it talks about the two ways to describe probability. One is using the entire population, and one is describing it as a single individual. Okay, so refer to page 177 for practice as well. Excuse me. So it says a large business surveys employees to find out how long it takes them to travel to work in the morning. Suppose that the morning commute time has a normal distribution of 32 minutes with a standard deviation of 9 minutes. Draw an accurate, careful normal curve with these parameters. Okay, so you had to do this on the midterm as well. So there's the mean at 32. And the gold sheet has the percentages for you to follow, 34%, 34%. And that is the first standard deviation, which means I take 32 and subtract 9. So that'll be 23. And I add 9, that'll be 41. That's one standard deviation away. And then the second one, I'm going to subtract another 9, so that's 14. And another 9, that's 5. So there's 13.5% here, 2.35% here, and 0.15% here. And so I always said outside of 1-2 standard deviations is unusual. So anything that way is unusual. And then we're going to mark over here. So the first standard deviation above was 49, plus another 9 is 50, plus another 9 is 59. And this is the 13.5. This is the 2.35 and 0.15. And so anything outside here is considered unusual as well. So B says the company is interested in a group of employees that take 45 minutes or more to drive to work. So 45 minutes or more. So that is somewhere in between 41 and 50, right? We don't know exactly. So I'm going to mark 45 here for myself. And then I'm going to shade it 45 or more minutes. Okay. We know it's at least 2.5%, and then it goes into this other category. So maybe around, we don't know, 8%, 12%. But right here it tells us, it says, suppose the area under the normal curve shaded in part B is actually 0.0743. So this right here is 0.0743. It can also be written as 7.43, but you have to add the percent symbol. And it says, provide two interpretations of this area in the context of the situation, one using proportion and one using probability. Okay, and so this goes back to page 177 in our course pack here. So the proportion of the entire population with the characteristics. So let's do that one. So the proportion of all employees that take at least 45 minutes, because we are shading bigger than 45, so 45 or more, 45 minutes, at least 45 minutes to get to work is 0.0743. So we refer to the population all. So in the second interpretation, we are going to refer to, excuse me, a single employee, the probability of a single selected individual. So we are going to write the probability of selecting a single employee that takes at least 45 minutes to get to work is 7.43%. So notice that this one, the first one, I used a proportion, so I just used the decimal form to describe it, referring to the population of all employees. And the second one, I was referring to a single employee, and I used it in percent form. So those are the two interpretations. So no, this is a bigger concept. So more than likely, this concept will be on the final in some way, shape, or form. Hint, hint. So let's take just a minute here and turn to worksheet for 7.2. And I'll let you get this out. It's on page 569. And then when we come back, make sure that you have your Desmos open as well. Okay, so we are looking at the worksheet for 7.2. And 7.2 is all about finding probabilities from this normal distribution and finding particular probabilities, such as ones that don't follow on those exact breakpoints of the empirical rule of the 1 standard deviation, 2 standard deviations, and so on and so forth. So our first example here says, suppose X has a normal distribution with the mean at 200 and the sigma at 15. Find the following. So using these parameters, 215 in StatCrunch, we can find all kinds of probabilities. So we did the same thing with the binomial distribution, and now we're going to do it with the normal distribution for quantitative data, quantitative continuous data. So the binomial was for the discrete data back in chapter 6. So let's draw some of our pictures, and then we'll go to StatCrunch to work on this. So it says the X value that corresponds to the first quartile. So there's some things going on here. So on these, I'm just expecting you to draw your mean is all, and then the piece of information that you're looking for. So we want to know an X value that corresponds to the first quartile. So the first quartile is that Q1, and that represents 25% below. So that means 25% is underneath this particular X value is our question mark. And we know that the area is 0.25 to the left of that value. Okay, so the probability that X is less than something, right, is equal to 0.25. This is what it's going to look like in StatCrunch. So let's go do this one together. So I'm going to share my screen here so you all can see. So in StatCrunch, we're going to go to Stat, and you're going to choose Calculators. And in Chapter 6, we chose Binomial here. But today, we're going to go to Calculators, and we're going to go down and choose the normal curve. Looks similar. And now our parameter is the mean of 200. And our standard deviation for this situation is 15. And we want to do X is less than or equal to, but we don't know the X value. We do know that it's 25% or 0.25. So we can see that that part's blank right here. And that tells us that X must be 189, and we'll round to 2 decimal places, 88. 25%. Fall below 189.88. Now that we have this in, these parameters of 215, we can go ahead and answer the other questions. So for B, it says the percentile rank of X is 178. So again, on my paper, I'm marking 200, and then I'm going to mark where 178 is. I'm going to go back and share my screen so you can all follow here. So 178 is going to be to the left, because remember this down here is like a number line. So this is 178. And percentile rank is always percentage at the bottom 0 all the way up to our value. So that's going to be a left shaded. So the percent is what we're missing. So in our normal calculator, you're just going to go back there and you're going to leave it at a less than or equal to, and this time you're going to put in the X value of 178 and then hit compute. We already have the 200 as the mean and the standard deviation of 15, and you should have gotten, so this is what this looks like on the paper. You should write probability of X is less than or equal to 178 is equal to 0.071. .0712 we'll go with. Okay. I'll share that with you here. So what I have on my screen here is from part B. And the 200 and the 15 were already there, and we said less than or equal to 178 and hit enter, and it gave us the probability of 0.0712. So part C says, what is the probability that X is less than 190 or greater than 225? Okay, so these are two separate things because they're disjoint. You can't be less than 190 and bigger than 225 at the same time. So we could do them separately and then add them. Or let's see here. See what the picture looks like. So this is what we want, is these two shaded blue pieces, and to add them together. So what we could do is we could say, to find the blue, we could say 1 minus the white space, right? And so that is just 1 minus the probability of X being between 190 and 225. So let's do that. Let's find the area between them, 190 and 225. So let's go back to my So we're going to click on the between, and so the between is going to be between 190 and 225, and hit enter. And so what we really want is we want this white space out here plus this space out here on the right. So we're going to say 1 minus 0.6997 and that comes out to be 0.3003. So we want the white space, and what they gave us here, 0.6997, is the red space. So we have to subtract that from 1. So that's what that looks like. So letter D says the score that cuts off the top 5%. So top 5% means we're on the right-hand side. We want a score, so there's our 200. We want to score X where there's only 0.05 to the right, the top 5%. So the probability that X is greater than, because that's the top 5%, greater than some X value, where that's equal to 0.05. That's what we're looking for. Let's go to that crunch. And this time we have to do a greater than or equal to And we don't know the X value, but we know the probability is 0.05. And so we can hit enter, and that X value is 224.67. 224.67. So E says the X value shown in the graph. The X value shown in the graph. Okay. So on our paper here for E, we want the red. Okay. So again, this is similar to C up here. We need these values out here. So we're going to subtract away the in between. But we want to know the X values this time. So we already know the area. The area is both the same, right? They're symmetrical. So this one and this one here. So that means we can go to the between, and we want the between to be as such that we have 0.12 plus 0.12, or 24% of our space. So we want to know what X values to equal 0.24, so that there's 0.12 and 0.12. So let's go to StatCrunch and check this out here. So we have to choose between, and we don't know the values, but we do know that the area is 0.24 together. So there's 0.12 over here. Oh, no, we know that the area is 1 minus 0.24, right? Because we want the X values that mark what's inside, which is 1 minus 0.24, which is 0.76. So that should be 0.76. There we go. So 182.38 is the lower bound, and the upper one is 217.62. I'm going to go back and show you my paper here. So if this is 0.12 and this over here is 0.12, then this is what's left over, 1 minus 0.12 minus 0.12. So that's going to be 0.76, and that's what I had to use in the last one. So the last one, letter F, says the area shown in the graph. So we want to know the area that is less than 218 point. What's this? 218 points. And then focus. So 218.6. Okay. So we're looking at the probability that X is less than or equal to 218.6 is equal to what? And so we're going to go back to StatCrunch and enter this in. And we are at a less than or equal to. And we said 218.6, enter, and that comes out to be 0.8925. So that rounds out the very first page of this worksheet. And now we're going to flip the page. And question 2 is similar to like the funny one in 7.1, where we didn't know all the spots, but this time we do know enough to use StatCrunch. Because it says in 2013, the amount college students charged annually on credit cards was normally distributed with a mean of 3,156 with a standard deviation of 623. This distribution is shown below with some areas shaded that are not equal in size. Find the 3 missing pieces of the graph of this distribution. So we're missing 2 areas, and then we're missing an X value. So there's a couple of places that we could start. I'll let you start this on your own and see where you want to start first. So first we're going to find these pieces and we're going to answer questions. So I'm going to find this one here first using this area. So this one here is going to be this in my StatCrunch. It's a less than, we don't know what it is, but we know that the area is 0.146. Now you could have also started over here. This one up here is we're finding an area. So this is the probability that X is greater than, because it's shaded to the right. 4,200 is equal to what? Now, remember, you have to change in your StatCrunch the parameters because that's all changed. So this new problem, it says the average credit card balance is 3,156 with a standard deviation of 623. And we want to find it greater than 4,200. And that comes out to be right here, 0.0469. And then we can also find the value on the left. So that was going to be a less than, and we don't know that value, but we do know that the area was 0.146. And so that value is $2,499.52. Maybe I can share my screen so you can see much. Okay, so you could start it, you could have started with either of these. Once you know the 2 areas here, you can subtract those from 1. So 1 minus 0.146, subtracting 0.0469. And that will give you this big white area, or area number 2. And that area comes out to be approximately 0.807. Using these areas, B and C are asking us to interpret. So B says, interpret the value of X2 in context of the situation, which means I wanted to talk about this story of credit cards. So I'm going to say it's 4,200. So approximately, because I'm approximating this percent at 4.7%, approximately 4.7% of college students in 2013 had at least, right, because this is shaded bigger than, so had at least $4,200 in credit card debt. And the second one says, interpret the value of X1 and X2 and A2. So we want to interpret this space in between here. So I'm going to do approximately. So approximately 80.7% of college students in 2013 had between, because now we're between two values, between $2,499.52. So we could have rounded that to 2,500. So between about 2,500 and 4,200 in credit card debt. That's what they charge annually. So not necessarily debt sitting on their credit card, but that's about how much they charged overall throughout the year. So we did some interpretation and we found some values on the curve. Okay. So the next question, question number 3 for this worksheet, is another scenario we're asking some questions about. And it says the average number of jobs available for registered nurses is normally distributed with a mean of 103,900 and a standard deviation of 8,040. So we need to make sure that we're shading, and don't worry about your calculator entry on the worksheets, but I do want you to tell me what it looks like in StatCrunch. Okay. So it says probably the X is greater than 100,000, interpret. Okay, so let's draw the mean. I'd like to at least get that on there so I know where my values are left or right of the mean. So probably the X is greater than 100. So the mean is 103, so that means 100,000 is just to the left. So 100,000 is there, and we want to find it greater than 100,000. So we're shading all of this. Okay, so we're saying 100,000 is equal to, and we're finding this. So we have to change all of our parameters in StatCrunch. So the mean now is 103,900 with a standard deviation of 8,040. And let's just go there so you can see what it looks like. So here I put in my new parameters, my new mean and standard deviation, and we're looking for a greater than 100,000. Enter. And it says that it's 0.6862. 0.6862. And it says interpret. So approximately 68.6 0.62% of jobs of RN jobs. So 68.86 of the year. That's what we want to say, of the year. There are 100, at least, right? 100,000 jobs. At least 100,000 RN jobs available. That's a lot of jobs in that category. So about approximately 68.6% of the year of the time, right? There are at least 100,000 RN jobs available. It says find the probability that more than 75,000 but less than 90,000 RN jobs are available. So if our average is at 103,900, then we're talking somewhere between here, right? So that would be the 75,000. And this would be the 90,000. Okay. So this is a between. What's the probability that the number of jobs is between these two values? We can do it between and StatCrunch. We're doing 75,000 and 90,000. And that comes out to be 0.0417. So 0.0418. Part C says, suppose there is 4.56% chance that more than X amount of jobs are available. Okay, so this time we know a percentage. And it says, suppose that 4.56% chance that more than X jobs. That more than X amount. Okay. And it says 0.0456. So let me just show you what that would look like here. On that paper. So we're looking at this. So 5% of the time there's more than what amount of jobs. So X is more than what? 0.0456. So that's just a single one on our, we don't know what that is. So we're going to 0.0456. And it is 117,480.38. So only 5% of the time, or not even 5% of the time, there's more than 117,480 jobs, RN jobs. This must be in our nation. Didn't say if it's in the US or in the world. So that wraps up the 7.2 practice. 7.3 practice is all about assessing normality using a normal curve here. And this is referring to your course pack Assessing normality on page 187. And if you need to assess normality, you're going to learn when you need to do this in chapter 8, actually. So if you have a small sample size, you're going to have to assess normality using this plot, a normal plot, and we will give you the plot, so you will never have to create it. But we want to do is we want to make sure that our normal probability plot is approximately linear. So this one would be good. This one down here is not linear from your course pack. So here on the worksheet, we're just looking for linear or not linear. And so this first one is good because it's linear. Yes, we can say it is coming from a normal distribution. Because it's linear, because it is linear. And then the one below says, is it reasonable to treat the sample coming from an approximately normal population? And we'd have to say, no, this is on the level of impurities in 24 aluminum cans. And that's no, because it's not linear. It is not linear. And that's all we have to say. So 7.3 is nice and short. So focus on chapter 7 for your project. Also, I'm going to share and look at your project here momentarily. So if you go into JetNet and click on your chapter 7 project right here. Oops. No. Right here is the link to the project. We're asking you to learn some things about the normal curve. And so I'm asking you to find the home run distances. It's a StatCrunch public data website. So when you go into StatCrunch, you're actually going to go from this screen right here, and you're going to click on not my data, but you're going to click on data sets, and it should come up with the public ones, and you're going to search for the one that says home run distances. So let's do that together. Home run distances. And you're going to use this one right here. It says home run distances. Home run 2017. I think maybe I chose the wrong one. Let's see. Let's see. No. Oh, I think it's just home runs 2017. Home run 2017. I think. Yep, home runs 2017. It should say M. Sullivan is the creator in 2017 right here. And it's this particular data set right here. It's loading. So this is the one that you're looking for. And then it asks you to draw a relative frequency histogram on the home run distances using a lower class limit of the first class at 310 and a class width of 20. So a relative frequency histogram. So in here, you're going to go to histogram, and you're going to choose on distance, because they want on distance. and they want a relative frequency. Oops. So you're going to go down here to under type, and you're going to click on relative frequency and hit compute. Now they said they want the first class to start at 310 and a class width of 20. So you can go into here and hit edit, because down here you can change all that. So they want the bins to start at 310 and the width to be 20. So 310 and 20. And then you can hit compute, and it should look like this. Then it says determine, so then you're going to answer some questions about the shape. Then it says determine the population mean and standard deviation distance of a home run hit here. So that's in the summary statistics, right? We've done summary statistics already. You're going to find those. Then question 3 says draw the normal curve with the mean and standard deviation found in part 2. So whatever your mean and standard deviation is, you're going to draw a normal curve. And it says you can do this by selecting overlay distribution, choosing normal. So in here, in the edit, you can go back here, and down in here it says display options. So overlay distribution, and you can say normal, and it's going to say, okay, what mean and standard deviation do you want? And you can put those in. And if it was, I'm making this up now, so do not copy mine. You need to find out what the mean and standard deviation are. If it's 415, it would look something like this. I don't know what the mean and the standard deviation are. I do, but I'm not going to tell you. But you want to overlay all of this is right in your edit options. And you can do all of this right from the histogram. You're going to choose the distance. You're going to do the relative frequency. You're going to tell it where you want to start at and your bin width. And then you're going to say overlay and normal. And you're going to tell it the mean and standard deviation of what you wanted to overlay. Then it's asking you some questions. So you can use your frequency histogram that you create to answer the questions down here. Okay. If you have any questions, you can send me a question. You can send me an email. And that is all I have for today. So have an awesome day. You can always schedule some tutoring, or you can schedule me for a Zoom tomorrow, or come to the live session on Thursday, or send me questions that I can answer in the live session on Thursday regarding the Chapter 7 worksheet. The live session on Thursday will be over Chapter 8, but I don't mind answering some questions about Chapter 10. So have a great day.